Step number 2, mark the intersection points. Mark the intersection points. And step 3, just write them as coordinates. Write them as coordinates. Okay, so let's do the left-hand side first. You're going to tell me, since I already taught you this on Friday. So as a group, figure out how do we do absolute value of x plus 3. Okay, y-intercept of, okay. Why did I count so many points?
So you know, like when it hits the x-axis?
Yeah, so when it hits the x-axis, and then I've got some points to flip up. Awesome. Awesome. What shape should you have for an absolute value graph? Awesome. It was the same point for -5, -2, flipped up to be -5, +2. I'm just going to label it so when we look back, we know which was which. Step number 2, we need to graph the other side of the equation, which is just y equals 5. So we go to 5 on the y-axis, and it's a horizontal line.
Sorry, what does that say for y equals?
The absolute value of x plus 3.
Oh, I see. Are those test notes in college school?
I can't remember. Then probably no, I would have done it Friday. What are the two solutions? Is it -8 on yours? Because mine's halfway, but I could have been off. So I'm off a little. Okay, so we're okay with -8. And yes, I did have 2. Questions so far? So that was a linear absolute value. Here's the hardest they're going to get with quadratic. Again, we did this on Friday, so walk me through it. Mm-hmm. The only reason we use the lines is when we flip it, so not for the actual graphing. How do we get this onto here? Mm-hmm. They're pretty even. This one has less because it's shorter, so it kind of goes by the length of them. 3 and 4 were longer units, so they probably have more marks.
What's the hardest unit this year?
Depends on your brain. Lots of people struggle with trig. Lots of people struggle in the last unit because they didn't do all the homework. Some people don't like factoring, so then last unit, it's not a good one. Some people struggled sequences and series.
Yeah, that was my worst. I can't do that.
I'll show you closer to the exam how to prioritize, so how to figure out where you need to concentrate your time on.
I remember last year it was like the spatial stuff, like the cubes.
Yeah.
There were like 6 cubes. I could not do it, and like even estimating, I couldn't estimate.
And spatial is the opposite side of your brain from math.
Yeah, and it's like not really.
And boys are better with spatial than women are.
Yeah, because they like play with tools and stuff. It's like, oh, Barbies.
What was the spatial?
Spatial stuff is like if there were like 20 cubes, you could say how many sides on each cube, or like stuff like that.
Flip from -2, -3 up to -2 plus 3. Same with 4, -2 to 4, +2.
Except I had it at -3.
Oh, negative, my bad, yeah.
Hayden's got the flipping part down pat.
Oh, yeah. Oh, right, we have to do the other stuff. Same.
Oh, I just did a wrong one.
We have to like do some math to figure out when it's not exactly on the point.
Well, we have to go back. We've only done half of step 1 so far.
Your W kind of curves in. Mine kind of curves out. Is that okay?
No, it would come in because it comes in here, so it would come in here. So they can't point out, because they don't point out down here,
Mine.
right? Because this comes this way, so it's then got to come the same.
Just drew the arrows.
Right, parabolas don't go out, parabolas come in, like,
So you just make it curve. I thought they like.
so parabola doesn't go like this. Right, they come kind of in this way.
Like, can I just show you what I did? Because that's what I thought I did. Like, I drew it down like that.
No, you got to bend down here.
Oh, okay. Thank you.
There is a graph like that, which you'll meet in grade 12.
I would like to.
Oh, isn't that like really sides?
Okay, what do you want to do with the 2? So it just comes from the right-hand side of the equation. I'm okay with ishing it. They're fairly close. Mm-hmm.
Three, two, positively two.
And just to be clear, you are okay with cost savings.
Mm-hmm.
Oh, 4, 2. Wouldn't it be 4, 3? Wouldn't it be 4, 3?
All the y has to be 2 because it's right on that line. So the y values all have to be 2.
Oh, why does mine?
Oh, wait, that's true.
Oh, I see, because it has to be 1.
Questions so far? Okay, you tell me.
Oh, it's already,
I like this game. Let's work for me.
it's already in the slope direction with stuff. Vertex.
Okay.
Okay. The vertex is 0, negative, or 0, -10.
I wouldn't because that's going to make this a completely different parabola where this is already in completed the square form. So if you start taking over an x, then you've got to recomplete the square, which I wouldn't want to do. So generally with this, we don't start moving from side to side. Yes.
Vertex is 0, 9, or 0, -9.
I'm just writing down what somebody says first, so if there's a mistake, change it. I am giving no opinion on this one. I'm giving no opinion on this one.
Okay, so let's grab that.
Okay.
Oh, so like because it's absolute value, we need to start at positive. Like, go do the other thing first and then increase it.
We could just like put it there after flip it up.
Okay.
Yeah, so
Or
start,
I could be completely wrong. I don't know.
Okay.
start at -9.
Got it.
Then you go up 1, 2, 5.
1, 2, 3, 4, 5, 6. Into the big part.
Now flip it to.
Technically, can't you just flip the parabola? Like, not the actual parabola, but the stuff that's on there?
Yeah, so flip it up to 0, positive 1.
You start at the intercept of 3. And then go down 1 over 1 to the right.
Oh,
Because it's a negative x.
that's cool.
Opposite the other one, right? 6.
Someone's going to watch this video and think that it's on mute.
Your intercept's at -4, 7. Or that's, yeah, -4, 7 for the first one. -2y.
Yeah.
0, 3.
Wait, so it'd be
Then -2y.
3, 0? Would that be 1? -4, 7.
Yeah, it's a 7. Because that's actually a 1 there.
Oh, I don't even have that on there.
And then
If you're confused, ask questions. Confirm. Questions? Yep, where the two cross. Questions so far? Algebraically. Create two different equations. Create two different equations using the positive absolute value and the negative absolute value. Create two different equations using the positive absolute value and the negative absolute value. So basically the same thing we did when we did the piecewise function on Friday. Isolate the variable. Okay, so how many units away from 0 is 6?
Oh, okay, yeah, never mind.
And how many units is negative 6? So if I just say the absolute value is 6, what did we start with, right? Positive or negative, we don't know. Isolate the variable. Grabbing red pen for the last step. Check your solutions. Check your solutions by substituting into the original equation. Where have we seen that before is the last step?
Oh yeah, if there was like a real number.
Kind of.
I forgot what unit that was. I wasn't sure.
Not when we factor. It was solving some kind of equation.
Quadratic.
Not quadratic. We never check quadratic. Okay, what was unit number 1? What was unit number 1 that we did?
Arithmetic.
Sequence in the series. Would we have solved any equations there? What was unit number 2? Radicals.
Oh yeah, we did.
So this is one of our special equations. First type we met were radicals. Second type we met were rational from last unit. That's where we check the NPVs. And the third type is absolute value. And then you meet the fourth type next year. Logarithmic. Good stuff. So absolute value is one of our special equations that we need to check. So I mentioned on Friday, a lot of times in science, we'll get out negative values when we know there shouldn't be. So then we just throw an absolute value on it to turn it positive. There's things in life we can't explain why they're negative, so we just change them. Literally, that's its function.
Everyone like Jason freaking cake.
So step number 1, we split it into two different equations. We take whatever's inside the absolute value and put a plus in front of it. And I know mathematically we don't need the plus there. I'm just showing you for the first one what we're doing. And then we take what was ever inside the absolute value, and we throw a negative in front of it. And so the first equation is just x minus 3 equals 2. X equals? The second one is these brackets are really important because that negative is going to apply to everything. So when we distribute, we're going to get negative x plus 3 equals 2. So I don't actually do the first step. Like I told you with piecewise, I just look at it, I keep everything the same, and then I just change all the signs. So x minus 3 goes to negative x plus 3. Negative x equals? X equals? And then we just check by going back to the original equation, absolute value and all. We do inside the absolute value first, so 5 minus 3. What's the absolute value of 2? So what's the distance on a number line between 0 and 2? This one we have 1 minus 3, so negative 2. What's the absolute value of negative 2? So what's the distance between 0 and negative 2? Conclusion? Two answers that both work, x minus 5 and x minus 1. Sometimes one will work and the other one won't. Sometimes neither one will work. Just depends on the equation. Do you have to show your work? No, but how do I know when I'm marking it that you knew to check? Right? You got to have something in there that shows me that you checked it. Questions? Number 2. I guess number 5. Oh, it's so dark without the light, but there's a shine. Oh, getting better. I always put the arrows just to remind myself that there's two different equations, because what your brain is going to do is just going to drop the absolute value and solve one. So that arrow is just a visual reminder for me that I know I need to do two things. I take whatever's inside the absolute value and I don't touch it. So 2y minus 1 is going to equal negative y plus 4. Then the second equation, take everything in the absolute value and just change the sign. So positive 2y goes to negative 2y. Negative 1 goes to positive 1. Why didn't I change the right-hand side? Why didn't I make this y minus 4? Because there's no absolute value. Okay, so you're only doing that positive, negative for the absolute value side. Okay, what do you want to do first here? Okay. Okay, add y to both sides. And y equals? The second equation? Okay. Check it. Ugh, fractions. What do we do with fractions?
Just times the top and then times.
Yeah, so we're going to do the bedmath stuff first. So these act like brackets, so I'm going to do inside the absolute value first. Just remember this is 2 on 1, so it's not 2 times 5 and 2 times 3. It's 2 times 5 and 1 times 3. So 2 times 5, 1 times 3, Now in the same step, let's change the 1 into common denominator. 3 on 3. The other side, I can keep my negative 5/3, but I have to change the 4 into a denominator of 3. Offer of 12. Ten on 3 minus 3 on 3. Negative 5/3 plus 12/3. Absolute value of 7/3. Conclusion? The other side? Inside that's the value, I've got 2 times negative 3. Minus 1. And on the right-hand side, I've got that negative 3. 3 plus 4 is 7. Absolute value of negative 7. Conclusion? Questions so far? 2 to go. Again, you don't need to put the arrows. It's just a visual reminder that I use to remind myself there's 2 equations, because what's going to happen is you're just going to solve the positive one. Now just be aware of where your absolute value is, because you're not changing the other side. So the first side is going to stay exactly the same. The right-hand side for the first equation. Perfect. And the other equation? Do you want to deal with the fraction or you don't want to deal with the fraction? If you don't, how can you get rid of it? Multiply everything by? Okay, you don't have to. That's just a choice if you want to get rid of the fraction. I'm not. That's a multiplying by 2. I just wrote it on the wrong side of the bracket. A half times 2. 9 times 2. 6 times 2. And negative 8 times 2. The other equation, a half times 2. Negative 9 times 2. Negative 6 times 2. And 8 times 2. Okay, what do you want to do on the first equation? Okie doke. Confirm.
Oh, you did negative A.
Questions on the second? Are we done? You tell me.
So it just doesn't
It just
work.
doesn't work. Yeah, the thing about math, I sleep on taking my time.
-3.
Solution.
So what is the solution?
There's
No solution to this one. How about a quadratic? Because we love solving quadratics. How many ways are there to solve a quadratic?
I don't know. 4 too many.
Oh, ouch.
Just kidding.
Really 3 too many.
Yeah, just like factor everything.
Actually, yeah. Do other like schools in other countries learn all the other ways?
In Brazil, I don't think they factor. They do everything with quad formula, right, Gabriella? Yeah, they love quad formula.
Gross. Why?
It's faster. When you get used to it, it's faster. Plus, they do the discriminant first, because if it's negative, then they don't bother solving it.
That's smart.
Oh yeah, that's actually really
But then
smart.
how do they do all the
If
rest
you're
of this?
factoring a lot though, you like lose it.
Yeah.
Because there's not so much you can do this one.
Factoring common.
It's x squared.
I can, but I want to finish this first. Did you text them and ask? Just go. I trust you. Just go. Don't do bad things. Sorry, the first one or the second one?
One of them.
Okay. No, I just have to do the positive first. I'm just left-brained.
It's nice for our notes too if it's all.
Always positive, always negative.
Yeah, it's factor.
Okay, you want to factor?
Factor
Yeah.
an x.
X take away. Oh, just kidding. I thought it was gonna be like.
Why isn't like just x?
It could have just been X. Well, what?
0 over x.
Could we have just gone like? Okay, never mind. I don't know.
See ya.
I don't think this is right.
Yeah, I don't.
I think that one's wrong.
Could,
Like, should it be x plus 2 x?
and X equals 4.
Oh, Bryn, you're so smart.
You're thinking James difference of squares when there's no x here?
Oh.
Yeah, I was doing it.
X equals -0. Forget it.
So you take out negative X take away 4. X equals negative 0. X equals 4.
Just show this that video.
Oh my gosh, we have to show you this video that Darren made. It's amazing.
What do we do now?
Check.
Check. CHEQE.
You can give me a check if you want to give me a check.
Give me a check at -0.
That does not make me happy.
I actually forgot on 2 different.
Obviously, because we have the same sets of answers, we don't need to check each one twice.
0 equals 0. Tough one.
It's like LOL.
16 minus 16.
Yay.
So x equals?